Hello everyone and welcome to another episode of the WeAreDevelopers Live Days. My name is Bene and I'm here at the headquarters of WeAreDevelopers in Vienna and I'm happy that you all joined us today. So, today is all about Web3 and the newest advancements in this area. But before we start with the first speaker of the day, quick reminder for our reoccurring viewers and as an info for our newcomers. The We Are Developers World Congress is back as an in-person event this year in Berlin, July 17th to 19th. Go to worldcongress.dev to get further information and to claim your early bird tickets. And now, before we start with the talk, quick reminder that you can interact with all the other viewers via the chat to your right. If you got any questions, submit them via the Q&A button. The speakers will gladly answer them after the talk. But as normal, during all these interactions, please be nice to each other and respect each other as you have a code of conduct. Here's a short video about it. And now let's kick off the Web3 Day with the first speaker of the day. He's tech lead at Near Protocol Regional Hub. Currently, they are developing a peer-to-peer decentralized file sharing product, and as he has a deep passion for innovation, he is committed to push the boundaries of decentralization. Very welcome, Alen.
Hi, Ben. Thank you for having me.
Hi, Alen. Thank you so much for joining us today. So, to kick off the day, would you mind sharing with us about what you prepared for us? What's the topic all
Of
about?
course. Thank you for asking. So, the idea for the topic today is to discuss chain abstraction and how is it the best way to build successful Web3 solution for users and how to enable them to actually have seamless experience through the application and the product.
Awesome. That sounds like the perfect topic to kick off a day like this. And before I steal any more of your talking time, Alen, the stage is all yours.
Thank you, Ben. So, hi everyone, and we are going to discuss today why chain abstraction is the best way to build a successful Web3 solution for users, or why bridging blockchain islands for a unified Web3 experience is the next step of evolution of blockchain protocols. So, first of all, who am I? I'm Alen Meštrov. I'm coming from Croatia. I'm a full stack software developer. I've been working in industry for 10 plus years, and I started with the web technologies, so web pages, web applications. Then I switched to, and I tinkered around with the hybrid mobile applications, a little data science, AI models. And after that, I actually I wanted to see and check out the Web3 because it has a promise, and this is the future, if you ask me. So let's start from the beginning. Introduction to Web3. So first, when internet came online and it came the go-to way of finding information, we had the applications that were giving the content out, but they had the username and password. So because they needed to know who you are and what are you reading, and to personalize the content and the everything that you want to read. So with this Web 1 approach, you needed to have username and password for every applications that you wanted to access. So you need to have a lot of usernames and passwords, and for each and every site, you need to remember their own credentials. So that was a problem. Then came Web 2 with the identity providers such as Google, Facebook, and Twitter, which you could manage, and they actually integrated it so that you, using by one password and one username, you can actually access multiple sites, which meant that you didn't need to remember your username and password for each site, but you needed to actually just remember one. The thing about this was they took your rights for your data and your privacy and ownership and everything. So they can always revoke your access to your account. And now comes Web3. So what Web3 stands for is your data, your privacy, your account, so your ownership. And how did that was by using the decentralization. So there is no single point of failure. Everything is in your hand, and everything is focused on the user. So you are the owner of your data, you're the owner of your actions, and everything you do is based on you, not on anybody else. So here comes blockchain, and blockchain is actually the backbone of that because it's decentralized. So it doesn't need to have one point of truth or one point of failure, because it is distributed all around the world. And with that, you can actually access, and nobody can say that you did something that you didn't. And that's actually the biggest part of Web3 now. So one of the blockchain protocols is Near. So Near had in his white paper actually from day one, the scalability, the interoperability, and everything inside of it, so that it can actually connect to other protocols that are currently based and that are currently isolated, which means that it actually is a solution that enables users by using one wallet to connect to other protocols without exiting the application and without the switching and going out and doing additional things and steps, so that it actually just streamlines the process. So the challenge of fragmentation. So I would like to have one parallel to it. So for example, let's imagine that every blockchain protocol, every blockchain is the island. And when you want to visit the island, you are visiting only one island, and there is no connection to another island, which is another protocol, which means that you cannot easily move from one point to another because it just doesn't connect. So this is the fragmentation that we're talking about today. And it complicates actually interoperability and user experience throughout the application process and the action that the user wants to take. Also, the challenge for developers here is when you want your application to be accessible by a lot of users that are currently distributed all around the network, and one group of users are on one protocol, the other one is on the other, the third is on the third. You need to have in mind that you need to do from scratch one thing to another and bridge it, and do things so that it's like a multiple work. This is how I would like to put it, is like when before, or I mean even now, when you are developing mobile application and you want to develop a mobile application for Android, you're going to use Java. But you still want to get the users from the iOS part, because it's a huge market and there is a lot of users that want to use it. Then you need to code in Swift. So this is that kind of problem that actually we are addressing today. So how to solve it and how to resolve it. So currently, how is it in most cases is this is like a use case that currently user needs to go to actually see and share and get from point A to point B. So we have Laura and we have Bob. Laura currently opens a hot wallet in MetaMask. Then she writes a password so that she doesn't forget it. She needs to open a separate wallet on Near, and then so this is all already, she went from one application to another. And then she goes to Starbucks to get a smoothie and she gets a points reward and NFT, which is on Polygon. So she needs to send that NFT to another Web3 marketplace, which is Polygon supported, to trade for special discount in Zara. So again, this is the third time she's moving away from the application. Then she finds an NFT special offer for a concert on marketplace on Near. So that's a fourth time, and for herself and her plus one. So after that, she wants to invite Bob to go to the concert with her. So what does she needs to do? Bob needs to actually she needs to invite him, and then Bob needs to actually do all of those steps again. This is so, like I mentioned, this is like 3 to 4 times exiting the application, moving, finding out the information after you did some action, and then everything is based on you. So in this case, Lara is going to stop on, I presume, getting the NFT from Starbucks. So here comes chain abstraction. So chain abstraction is like a simplification tools for blockchain interactions, which means that protocols, or in this example, Near, what he did, what was actually he abstracted the connection and the interoperability with other chains, so that developers and users can actually focus on the important stuff, such as functionality of the application, connection, multi-order, and stuff like that. So, which means that it actually derived the unified layer of engaging with multiple blockchains, and it can be done really, really easily because the wallet is set up, the Near wallet or Near account is set up in a way that it enables the users to have multiple keys for multiple protocols, and then based on chain signatures that we're going to discuss a little later, smart contract and the applications built on the protocol can actually connect to another protocols easily without worrying about interoperability and doing the complex stuff of building the application from scratch. So how does it look on Near? So Near has this unified UI, which is blockchain operating system, which is decentralized frontend. And this decentralized frontend is used to enables developers to actually create front-end applications that are built on smart contract itself. So they are decentralized by nature. And with that, we are getting the account aggregation. So here, if they can allow the user to actually generate the keys for their accounts that can actually connect to multiple chains. So we are talking about interoperability. So the user at the end will have one access, and then he's going to actually do it all by themselves through the process without exiting the application. And we will be able to communicate with the other users that are on the different protocols with ease. So with that said, this is the benefits of the chain abstractions in perspective of the user. So seamless access across blockchains is really, really important, because one chain has one cool product, one cool functionality. It is advanced on one topic that is really, really important, and you want to have it, integrated in your system. So when you're talking about benefits, if user doesn't need to exit the application 3 to 4, 5 times so that it can finish the action that he or she wants to take, then this is the seamless access. And this is what the Near actually is trying to do now. Also, with that said, the simplification of transactions. So we're going to get into that a little later. But the thing is, what does it abstract is these multiple steps, and it takes it into one step, so that the user just gets the final note, let's say, like receipt or action that he needs to take so that this action is done. So how it should be and how I'm thinking it will be the best to do it is in a way that Laura opens one app, then she orders a smoothie in Starbucks. Automatically, she's granted reward points and NFT. And then she does, so she's automatically notified about this NFT. And she gets a badge, she does the shopping, and with the push notification and all of the chain abstraction, she just reopens the app, gets another offer for a concert because the applications manage to scan all of the market and all of the actions that can take that Laura can take, and she sees that she can get one concert ticket with a +1 for her. So she sends a ticket to her friend Bob, and everything is done. So Bob actually gets the notification, so he doesn't need to, you know, create it or do something else. So we are removing the complexity here. And after Bob receives the ticket, he scrolls through the application. He sees that there is this awesome NFT fighting dragon on Magic Eden. So he purchases it through the applications. He doesn't need to exit the application, enter the another application, and then, you know, this streamline process is broken. So with that said, with the chain abstraction, the point is to actually get the user to stay at one place and do all of the actions through one application. So there is no side steps, there is no intermediate steps, and there is no exiting and entering the new applications. Everything is in one place. So with benefits for developers. So when you're a developer and you want to develop your application, and you start with the application and you have knowledge of one perspective area in that application, and you want to have it for multiple users, for, you know, as large as user base as you can get. So what happens is you want to have like a SDK or the package that actually enables you to communicate with as much as you can, as much as protocols or databases or users bases that you can have with that. So this is the most important benefit for developer. It abstracts, or actually it simplifies the process of your application communicating with the other protocols, other backends, for example, and getting the users from there. So with that said, the thing is, you get access to a broader user base and the freedom to innovate beyond technical barriers, which means that you're going to focus as a developer, you're going to focus on your application, and you're not going to focus on connecting to the third-party service or to the third-party protocol or, you know, something third. How does NEAR does it? So NEAR introduced chain signatures, and here you can actually, with this slide, you can actually see how does it look. So you have NEAR account, which actually can store the smart contracts on them, and that the smart contract can actually sign the transaction on any blockchain, because NEAR now has access to the Ethereum network and Ethereum layer, and you can actually send money with the NEAR account to I don't know, Ethereum, ETH or Polkadot or Bitcoin, everywhere from one point of communication, which means that you have NEAR account, and then if you want to send, for example, you have Polkadot and you want to send 100 Polkadot to Ethereum account. So first, what you need to do, what would you need to do? You would need to bridge Polkadot to NEAR, so to a one account on NEAR, so that actually you get the tokens from DOT to NEAR, and then you need to send from one address on NEAR to another. This is what NEAR resolved with the help of IGN layer, so that actually everything is compiled in batch transactions. And what does it mean is that after with just a few steps in smart contract, you can actually do everything from here and with ease. So Near is abstracting that from the developers so that they can actually focus on the functionality of the application. So we have some case studies that are actually implementing this, and this is like a real world applications, like set economy, mean based is blue, which include integration of multi-chain gas relayers for transactions across near and BNB chains as well. So, for example, is blue is layer 2 DeFi, Bitcoin layer 2 DeFi developments, and as well Meanbase is cross-chain NFT marketplace. So they are all embracing this part of abstraction, because they know that if the user needs to go out of the application and re-enter through another application, he's going to get lost. So in general, user span and user concentration, if they need to do something additionally so that they can complete the steps, they're not going to do it. Or you're going to lose it unless it's, $100 million if you click 2 more clicks, So with that said, what we're trying to do and why chain abstraction is really, really important for this next steps of the blockchain and Web3 is that you are going to streamline everything, and you're going to enable users to do it with a lot of less effort. Let's say it like that. So the future is with the web chain abstraction. The future of Web3 should be powered by chain abstraction, and it is envisioned as a fully interoperable digital ecosystem where users will enjoy streamlined process, which means that they will be at one place doing everything, and then they will not be able, they will not need to actually exit the application, the product or anything, just so that they can actually connect to a friend or a colleague or a family, so that they can show them or they can share that with them. So for the end of the presentation, we wanted to show you how this blockchain abstraction actually is in works. So we have this NFT, proof of doing, which you can actually connect by scanning this QR code. And yeah, you will get this NFT for finishing this presentation and this talk, and you will see that it's not that hard. So let's say that yeah, so we are open for Q&A, and I'm going to leave the documentation and everything in the last slide. And yeah, that's actually it.
Hello again, Alen. Thank you so much for your presentation. Yeah, we can share your presentation and also documentation also via the recap mail that goes out on Friday. So just send every link you have to us, and we will include it, of course. So, Alen, to start off the Q&A, I think also some of the audience are interested in maybe you yourself, your developer journey. Would you mind sharing a bit with us about how you got interested in tech at first, and how did you get there where you are now?
Thank you for the question. So I started with the web development in WordPress actually, and it was really, really cool to see how people are building their products, how you can integrate the one solution so that it corresponds to another problem. And then with this building having in mind and this advancement and everything, I started to continue down that path, and it started to make something out of nothing. by using the current technologies that are available, create new one and create new use cases and create actually new experiences for the users that are going to bring the benefits to them. So how I started was I was tinkering around, and then web applications actually managed to get my attention, and it lasted a long time before I noticed that there is a step that you can take after it, and that's, I don't know, personalized content and the application that you can do with analyzing the behavior of the user using data science and AI models, so that you can bring even more desired output for the user. So yeah,
All right. Thanks for sharing this with us. Also, nice to see that you started with like very user centric, very how can the user profit the best? And I think that's a very good approach to start with.
thank you.
All
Yeah.
right. Then let's go on to some technical questions. First one. What measures are in place to maintain transaction security when utilizing chain abstraction?
So for this, for the transaction security, we are using, so we have, so in this way, we are actually leveraging the dual quorum security model. So we are leveraging EigenLayer and ourselves, so that we actually have two points of approval. Let's say it like that. So it's not a single point of failure. So we have like a multiple quorum and dual quorum security model combining near staking and EigenLayer risk takers.
Right, thank you for that. Let's move on to the next one. How does chain abstraction impact the user experience in interacting with decentralized applications?
Yes, so it benefits you. User experience benefits from that because you're not going to be needed to. You're not going to need to change the network. You're not going to need to. It's going to lower the steps that the user needs to take when doing one action. So it really benefits. Um, the user experience with the when user is actually interacting with decentralized applications, which means that we're abstracting everything so that the user can focus on the functionality of the application.
All right, thank you for also shedding some light on this topic. And we got another question. How does Near Protocol handle data interoperability, sorry, difficult word
Interoperability.
for me,
Yeah.
in the context of chain abstraction?
So we have these chain signatures that I actually explained. What we can do. So if you want to deep dive into these technical questions and everything, you can. I'm going to leave the contact. I'm going to leave the contact, and then you can ask me directly. But the thing is, so we are abstracting it. So you're going to get one thing instead of three things, which means that we are going to create multiple layers of process, and then we're going to say, okay, this is the price for it. You're going to pay it in here. And then what does it happen is you will be able to see all of those prices separated one by another. And then, but as the end user, if you're not a power user, if you don't want to see it, you're just going to see one receipt, let's say it like that.
Right, thank you. Next question. Can you discuss how the Near protocol works seamless integration of different blockchain networks in gaming application?
Yeah, so we have DevDep as well. So we have, um, okay, this is a little complex topic. So the thing is, we are currently working on partnerships and integrations with other protocols so that they can actually, can you discuss how the Near protocol works seamless integration? So this is going to be it's same as the user. It doesn't need to be gaming applications. The user application itself can be gaming application. So with me, what means is that when you're abstracting the interoperability, the different blockchain networks, you're abstracting for all. So when you want to send one thing to another network, you will be able to do it like this. And you will not need to go outside the application, change the networks, do all of the process by yourself. What you're going to need to do is you're going to just press the button and say, okay, this is it.
Right, thanks. Let's jump to the next one. How does chain abstraction handle different token standards across various blockchain networks?
Yeah, so currently chain abstraction, what Near did was with agent layer, with which is the risk-taking ETH. So we are through them we are actually getting the risk takers, and we are getting the validators for the different Ethereum networks, and then based on that we are adjusting the standards for it.
Right, thanks for this answer as well. We got another question. How does chain abstraction enhance blockchain scalability?
Yeah, this is a good question. So thank you for the question. The thing is, Near was built having in mind that. So when you actually use the infrastructure of the Near is built for 1 billion users, and we are aiming for that, and we are going to get to that. And the Near itself has this way of validating and doing the process. So it is scalable by itself. So since we had that in mind from the day one, we actually are ready for the scalability.
That's
And yeah,
core aspect of the product.
exactly. Exactly.
Awesome. Happy to hear that. So, do you have maybe some challenges to share when it comes to chain abstraction? Are there any difficulties?
So for now, no. The thing is, so that the user can get, so that the current users actually can get the knowledge and everything needed, so that they can actually adjust to it, because they will be baffled how there is not middle steps in it. But other than that, this is the next step.
All right, thanks. Let's talk a bit more about the Near protocol. How does the Near protocol impact transaction costs within the context of chain abstraction?
So yeah, with the Near protocol, we have these uh, MPC layers, MPC nodes that actually bridge everything, and then based on that, we are getting the info what amount is needed for the transaction based on what chain you want to move from and what chain you want to move to. So we are actually combining that price and into one, and then what we're getting is related payments in USDC. So based on that, you are getting the final receipt for the transaction. So there is no multiple. We are batching transactions from different protocols, and then we are converting it into USDC.
All right, thank you for clarifying this. Next question. If you can talk more, maybe have a sip of water in between, just
Yeah.
just to oil the throat a bit. So yeah, next question. What are the primary goals of implementing chain abstraction in blockchain ecosystems?
Yeah. So the primary goals of implementing chain abstraction is to get more user base, to get more functionalities, to get more products. Every chain has their own advantages and disadvantages, which means that when you are building a product, you are going to choose a chain that is best suited for your product. And if that product later on actually has benefits for another or partnership or interoperability with another product from another chain. So you will be able to connect those two, and then you get more functionality, more bigger user base, and everything that actually comes with that. So these are the primary goals: to enable users to have a streamlined experience inside the application itself.
Perfect. Thanks. Another question to the Near protocol. How does Near protocol support the integration of off-chain data sources and external APIs within its chain abstraction architecture?
No, okay. This is the question that we can leave for the for the later talk. Yeah.
All right. So
Yeah, we
then
can discuss it. We can discuss it. Yeah, there is a couple of solutions for it, but yeah, this is for support the integration of off-chain data sources. So the thing is, we need to. So there is a lot of ways for how the Near can do it and how you can do it actually, but there is also the approach of what way do you want to do it. So yeah, we can discuss it. It's a more complex topic. Yeah.
So maybe we already have a topic for your next talk at live.
Exactly.
Perfect. Then we leave this question for Dan. We get another question. What impact does blockchain have on traditional industries?
That's a fair question. So traditional industries have actually vendors that are single point of failure, and they are owner of your data, and they actually are in charge of everything that you have access to in a way that they own your account. So with blockchain, you have decentralization, and you have your own account, your own wallet, and you are responsible for it, which means that when talking about differences, it's you will not be in Web2, any the authentic provider can actually take away or revoke your access to the account. In Web3, there is no such thing. So impact is we are moving away from the user from the ownership of vendors to ownership of users. But traditional industries can also have more transparency through the blockchain, more validation and sovereignty and ownership. So they can show the users that they are transparent and they are doing their business as it should be, because it's on the ledger, it's on the blockchain. So yeah, that's actually how I see it.
Right. Thank you for sharing this with us. Next question about barriers. What barriers does Near protocol face in advancing chain abstraction adoption?
So Near protocol actually is currently head-on for this chain abstraction adoption. So we are trying to. So Near is trying to move it forward. So with the interoperability and the architecture of the other protocols and everything. So when we are trying to overcome those hurdles, let's say it like that, which means that only the way of doing things of infrastructure and everything for action that needs to be taken.
Right. Thank you. Next one is a very basic but nevertheless very essential question. How do users interact with blockchain applications in the first place?
So that's a good question. So there is a couple of ways. So what you can do, you can create your application, which is in Web2 way. So you have a server that serves the front end, and then the user actually goes through the server, and then in the backend of that server, you are actually connecting to the blockchains and protocols and everything, which means that you are accessing the front end that is actually communicating with the central front end. But there is also this decentralized, like a blockchain operating system, which actually serves as a. So when the coders or programmers are creating the application is compiled into the bytecode and stored on the network, on the blockchain. And then when the user wants to read it, he just needs to have like a gateway to read this from access point to the blockchain, so that he can actually read that content from the ledger. So there is two ways of doing it. We have decentralized, fully decentralized way, and half centralized.
Half centralized. Right, thanks. Next question. How does the Near protocol's chain abstraction features enable decentralized storage and content distribution networks?
Yeah, so it would need to be a little more specific. So what do you mean by enabling decentralized storage and content distribution networks? So in a what way? Let's say it like that. Yeah, we can do this topic also later, but I just need a little more information.
All right, then let's leave this for later. Next question. How does blockchain technology prevent double spending?
With validators and with nonces and with security measures that actually are in place for that not to happen.
All right, thanks. Very straightforward. What are some examples of industries that can benefit from blockchain solutions using chain abstractions?
Yeah, so any industry that actually wants to, give DeFi, then we have, for example, DeFi industries, then we have banking, then we have, let's say, financial, then let's say retail, then let's say everything that can actually bring the user. So the users are happy when they know what is done with their data. You don't want to see your data being sold on the side, let's say it like that, for something, for generation of revenue or something like that. So using blockchain, it just means that you're going to go full transparent, and that you're going to lean on the technology that everybody has access to it and everybody can check you, which means that any industry that want to be transparent to the users and give the users the right of ownership and sovereignty, they can benefit from the blockchain solutions.
Right, thank you also for that answer. Next question. How are transactions verified and added to the blockchain?
Okay, this is a simple
Very
question.
fundamental. Yeah.
Yeah, very fundamental. So the transactions are verified and added to the blockchain with the validator. So you have a group of transactions that are grouped into the block, and that block is verified, and then that block is added after some verification. That block is added to the blockchain. But there is a couple of consensus. Proof of stake, proof of work, proof of doing. So there is a couple of ownership and stuff like that. So as the time goes by, there arises a couple of new consensus, but proof of work and proof of stake is the most presented now. So yeah.
I also heard there was some time like proof of space, I think. When it
Yes,
was
like I said,
about,
so during going through the years and everything, there is we got how to say it, we have imagination, and then we can find a solution, and this is what I was saying. This is what brought me here. So the connection and the usability of one thing that is currently not used to its full potential actually can bring out the best and the new functionality, new use case, new, something that is not worked in one way is really, really worked in. So yeah.
Imagination and adoption is key, as in
Exactly,
so many.
exactly.
Right. Thank you for discussing this with us as well. We got another very fundamental question. Do you know maybe some potential drawbacks or limitations of the blockchain?
I mean, depending on depending on what kind of blockchain and everything, there is this gas cost, there is this transaction time, and depending on what blockchain are you talking about. So this is why there is a lot of protocols and a lot of solutions. Let's say it like that. So the idea is, with time you get upgraded. You resolve one issue, so to focus on one solution. And this is why there is a lot of diversity here. So every blockchain protocol or network actually can solves one or multiple things, and that's actually focus for that protocol.
Right, thank you. So now is your chance to
Okay.
tell us what are the top 3 reasons to use the Near protocol over others.
Yeah, so NEE protocol is built for scalability. It actually, from day one, it is used. It is driven by interoperability, and it is really cheap. So it is built in a way that there is no gas. There is little minimum gas fees, and everything is fast, everything is scalable, and everything is approachable by user. Everything, and the documentation and the technology itself are really, really good and advanced.
All right.
Explain.
Sounds reasonable.
Yeah.
Thank you. So, can you name maybe some of the key components of a successful chain abstraction implementation?
So first is user doesn't. First, the user doesn't leave the application. That's the first one. Then the second is you can connect. You get more user base. So no more users are actually using your application and interacting with other users that are currently on other protocols. And the third one would be, so once you can focus on as a product developer, or as a owner, or as a CEO, or as a product developer, you actually can focus on bigger and more important stuff. So these are the key components, let's say, for successful chain.
Right, thank you. Next question, in your opinion, how does blockchain technology impact other industry beyond the finance sector?
Yeah. So transparency and ownership and sovereignty of the data. So your action, for example, when you can place your deed of the house on blockchain, and then everything is up there. You can do your works on the house, and then for sure that nobody touched it, that this is it, that this is that you did this, and that nobody can actually think around it. Once you place it on the blockchain, it's there. So everything, for example, document signing and stuff like that, when you place it on the blockchain, it's there, so it cannot be deleted, which means that transparency, ownership, and sovereignty, this is really, really important part of that.
Thank you, Alan. And the last, I would say, more technical question, or maybe this is not that technical, but maybe do you have an outlook for us? What's the next big thing when it comes to blockchain? What's the perfect use case?
I mean, there is, yeah. So perfect use case, I would say, bring it to the government. So bringing it so that everything is transparent, so that there is no mischief, so let's say it like that, so that there is no how to say it, bribery and stuff like that. Everything needs to be on paper. Yeah. So something like that, I would say. But this is like a big thing.
But yeah, it's hopefully the next big thing.
Yeah.
All right, Alan, before we close the session, we talked a lot about Near and your team lead there. Maybe you want to give us some insights also on your typical workday there. What are the things you're getting done throughout the day? How is team communication? Things
Yeah.
like that.
So in Web3, you're learning everything. You're learning every day new things, so you're always researching, you're always investigating, and you're always developing, testing, and doing proof of concepts and stuff like that to see how it can be used, and how at the end of the day how you can use it for your benefit. So my day would be, start the day with coffee and talk to the people around you, to the team, and discuss what happened yesterday, and how we can proceed or improve, or bypass the hurdle that maybe happened yesterday. And after that, you're just in the code, reading and testing it, and doing everything in a way that research and learning. This is the most important part, because it is growing, it is adapting, and it is the evolution is of this kind of technology, and this industry is really great.
If somebody who is watching us today wants to join your company, are there any open positions yet, maybe?
So currently we are onboarding developers, and so in the near future we are going to have the possible open positions for the how to say, the internships, let's say it like further.
Okay. So always worth a look.
Yeah, exactly. We have it on our page, so yeah.
Talking about people who want to get into Web3 and stuff, do you have maybe some more content, some more information for them? Maybe who YouTube channels, bloggers, just to get in this sphere?
Just start reading. It's going to be hectic. It's going to be spread, but after some time, you're going to get to connect the dots, and you're going to see that everything is pretty much simple after you after you research it, and everything is connected.
At first, but yeah.
Exactly.
As with so many things. All right, Alen, then thank you so much for
having
some light on so many things today. It was a pleasure having you, and
likewise.
Hope to see you again on another live.
Thank you,
Alen. Bye.
Bye.
All right, and before we move on to the second speaker of the day, we're jumping into a quick 8-minute break. See you then. So, hello again. I hope our technical problems are now closed. I got an okay from director. Perfect. All right. Then let's finally move on with the Web3 day and the second speaker of the day. He is founder at OpenElements. He's a Java champion, GSR expert group member, and a Java 1 rockstar. He already wrote a book about Java FX, and he's also the founder and leader of the Java user group in Dortmund. Very welcome, Hendrik.
Hey,
Hey,
thanks for having
Hendrik.
me.
Yeah, thank you for joining us. Sorry for the wait.
No
So,
problem.
yeah, as it is with live production,
Yeah,
sometimes
absolutely.
everything at once. All right, Hendrik, but before we jump into your talk, maybe really quick, could you summarize your talk for us? Maybe just sum up the
Sure.
topic in some
Yeah.
words.
So the talk is a kind of beginner talk. So it should be an introduction to the, let's say, like Web3 ecosystem. Not coming from or concentrating on things like Bitcoin trading, things like that, but more concentrating on how you can use Web3, for example, in enterprise applications, and how you can use Web3 as a tool or as a platform to work with by creating your own code that works with Web3 ledgers, like, for example, so I have examples with Bitcoin, Ethereum, and Hedera. So I use those three networks and give an overview about those three networks, try to show the difference and yeah, what is actually behind all those buzzwords that are all around. That's the idea of the talk,
Perfect. So
actually.
let's shed some lights on all the buzzwords. Hendrik, thanks so much for the introduction. And I would say, without further ado, the stage is all yours.
Okay, perfect. Thank you. Yeah. So welcome again to my talk about blockchain, NFT, and smart contracts. I'm Hendrik. I'm from Germany. I live in Dortmund, and yeah, as already mentioned, I'm coming from the Java ecosystem. So I work, yeah, since even before studies, I did Java, and based on my open source work on Java and other work in the ecosystem and community, I'm a Java champion, and I'm heavily involved in open source. So based on that, I'm a board member of the Eclipse Foundation. And since some years, I have my own company, which is OpenElements, that concentrates on exactly those two topics, open source and Java. And one of the big projects I'm currently working on is the Hedera public ledger. So it's a DLT technology-based ledger, and there I work together with companies, Worlds Labs, as a contractor to develop the Hedera network. Next to all the technical, I love to play board games. I love Star Wars, and yeah. And dogs, actually. So anyway, so let's come to the content of this session. As already mentioned, I want to give an overview about the general technology. Here I use three networks, so which from my point of view show different iterations of the Web3 space and technology, starting from Bitcoin over Ethereum up to Hedera. And then I will give an introduction on smart contracts, what they are and what you can do with it. And if we have time at the end, I will talk a little bit about coins and NFTs and what is really the technology behind that. Okay, as said, I have a lot of things to show, so let's jump directly into it and start with Bitcoin and the history of Bitcoin. And I talked about that coming from my ecosystem a lot on Java related conferences and on Java user groups and things like that. And at the beginning, I always ask, like, do you know who Satoshi Nakamoto is? And A lot of people have no idea about this name and who it is. Maybe you have a kind of idea who that is. If not, that is the name who invented Bitcoin. So why do I say that's the name and not that's the guy? Yeah, maybe we will see in a second. But in 2008, a white paper has been released, the white paper of the Bitcoin network, how Bitcoin works, and it was released by Satoshi Nakamoto. And so you can just go to bitcoin.org or find it online on any pages. You can even find like translations in different languages about that. And what it contains is how Bitcoin works and the goals of Bitcoin. And the goals of Bitcoin are in general to create an everyday currency, which means like you have a currency that you can use in your daily business, like when you buy a pizza, when you buy some bread, or when you give money to a friend or something like that. Then it should be a common currency with less exchange costs. And instead of trusting banks, it should have a cryptographic proof that is good enough for really trusting it, instead of having all these big bank institutes where you put your money in and trust them. So from the beginning, the invention of Bitcoin and the implementation has been done in the open. So Bitcoin is an open source organization and project on GitHub. So the Bitcoin client you can find under the link that is shown there. And next to releasing the paper, Satoshi Nakamoto started the implementation of the Bitcoin software in 2009. So now we heard a lot about Satoshi Nakamoto. So the question is, who's behind that name, right? So the interesting part is, whoever that is became inactive in 2010. And since it's a person on the internet who never met somebody in real life, nobody knows who Satoshi Nakamoto really is. It could be a person, it could even be a group, right? Because it's really just one account that created the white paper, one account on GitHub, and so on. And over the last years, several people claimed to be Nakamoto, but always the press or investigators proved that those people are wrong and are not Satoshi Nakamoto. So why somebody wants to be Satoshi Nakamoto? Well, that's quite easy, because he is really rich. So he has a Bitcoin wallet that has over 1 million Bitcoins. And when seeing like how much one Bitcoin is currently worth, you can assume that whoever is Satoshi Nakamoto, especially if it's one person, it's a really, really rich person, actually one of the richest persons on the planet. But up to now, nothing happens on this wallet or on the account. So the Bitcoins are just there, they are not used, and nobody knows who's behind that name, and it's still inactive till today. So that is one thing on the Bitcoin network that some people may not know. And before we go into like what is a transaction and how this network is really working on, another point that is quite interesting is the problem with the use of coins. So I found a report that says that in 2017, so that is really several years ago, like 3 million Bitcoins have been lost, which is like, a lot of money, a lot of money. So how can those Bitcoins be lost? To answer that question, we need to see like, how can you use Bitcoins and how can you trade with Bitcoins? And to do so, you need something that is called a wallet. So a wallet is a piece mostly of software that you use to interact with the Bitcoin network, or in more general with crypto networks, because in Ethereum, in Hedera, or in any other network, it's actually the same. You as a user have a wallet that you use to interact with the network. And one primary goal and function of a wallet is to store your public key and your private key that you need to get access to the network. When talking about those two keys, you can think about like the public key is like your bank account ID. That is something that identifies you, that you can easily share with other people, especially if they want to send you some money and so on. And your private key is then more like your banking password, right? That is what you should not share with anybody, because if somebody has that, he can do transactions in your name, and that is definitely not what you want. But there's one big difference against this and like an online banking account, because if you miss that information, like the public key and the private key, there is no bank employee that can help you by resetting your password or something like that. Because so this only belongs to you and nobody knows about it, right? And based on that, if you lose your public and or private key, you have no access to your money anymore. That's why it's so important to have a wallet where the public and the private key is stored in a secure way. So next to storing the public and private key, wallets mostly provide the functionality to call transactions. So you can use a wallet in the Bitcoin network to easily send money to another account, for example. Why do I see mostly? Because the most simple wallet could be like, oh, I have printed my public and private key on a paper. We could call that a wallet too. And in that case, yeah, you cannot use that paper to do a transaction, right? But all the other things we see here on the screen, like applications and even hardware devices, all that have a rich experience that allow you to not only store your information like the public and private key, but do transactions too. So when going back to the question about the goals of Bitcoin, based on what we've seen so far, so has Bitcoin achieved those goals? Actually, we do not know that much, but one thing we can already say, right? Because creating an everyday currency, that is not what Bitcoin has achieved. So I do not use it every day, and I assume you neither, right? So maybe there's somebody watching this video who says like, oh, I do everything with Bitcoin, right? But that's not common. So for most of the people, mostly all people, Bitcoin is not an everyday currency, and it's not used mostly everywhere. So you cannot go to the supermarket and buy a pizza by using Bitcoin, for example. So what is it actually? Is it a game changer, or is it more a hype that we see here? So especially when talking about the hype of crypto, you can see quite good the FOMO program, the fear of missing out program, where people start to trade with all that. You can trade Bitcoin, you can trade Ether, you can trade HBAR. There are so many coins, digital coins, crypto coins, tokens on the market where you can trade with, where from my point of view, a lot is, I don't know, so special, and people trade with coins. They have no idea where those coins are used for. Just because there was a big of media hype and buzz by influencers and celebrities and so on. And based on the fear of missing out, people invest a lot in crypto, even without knowing what they're actually doing, which is a problem from my point of view. But on the other side, there are real use cases. And even if Bitcoin is not the currency that you use every day, in general, Web3 and crypto and distributed ledger technologies have a lot of great use cases. And I will show you one specific use case where a POC has been released some time ago, like 4 months, 5 months. So let's assume you live in South Africa and want to transfer money to a person in South Korea, maybe your mother or whatever, right? So let's be more concrete, because those are the partners where this POC has been established with, which is the Standard Bank in South Africa. It's it's the largest bank in Africa, and the Shinhan Bank, which is the leading bank in South Korea. So, and if you have an account on the Standard Bank and wants to transfer money to somebody in South Korea that has an account in the Shinhan Bank, what do you think? How long does it take? And what do you think? How much does that cost actually? So I have the results for you. The fee for such a transaction is $40 or higher, and it took up to 6 business days. So we are not talking about 6 days, right? We're talking about 6 business days. So there could be like 1 or 2 weekends in between. The transaction cannot be tracked, right? So you send your money, and for 6, 7, 8 days, you have no idea what happens with your money, and the other side just do not receive anything. And if you have any problems, yeah, you really have a problem in that case. So for that, Hedera or the Standard Banks and the Shinhan Bank created a POC using Hedera as a distributed ledger to create a new way how such transactions might work. So today, without having a distributed ledger in it, a transaction works like that. So instead of sending money directly from the Standard Bank to the Shinhan Bank, we have this, I call it global mega banks, like one bank, for example, in Africa, one bank, for example, for the Asian market. And as you can see, instead of directly communicating with each other, the money needs to go over those global banks. And that is what takes so much time, what creates so much cost, and so on and so on. And what those 2 banks did is they created cryptocurrencies that are stable coins regarding the currency of the nation. So let's say like there is a digital South African rand that they created in Hedera, and there's a digital South Korean won that they created in Hedera. So 2 kinds of cryptocurrencies they created in the Hedera network. With only having these 2 parties the ability to trade those cryptocurrencies. And since they are stable coins, this means that one cryptocurrency is defined that it has the same price as one coin of the real currency. And then they interchanged some of them so that both still have the same value, but both have cryptocurrencies that are like South African cryptocurrencies and that are South Korean cryptocurrencies. And if now a transaction happens and a person wants to send money from Africa to Korea, they do the same transaction in the Hedera network. And on the other hand, somebody just listens to the event, receives the event, and does the transaction with the real account. And by doing so, since the coins in the network have a defined value that is defined based on the real coins, such a transaction, instead of having a cost of $40, is less than 10 cents. Actually, those 10 cents are not what you need to pay on Hedera to do it. That already creates the money the 2 banks wants to have as a fee to do that transaction. And it needs less than a minute. Again, on the network, that is even way faster, but with like all the software that happens on the one bank and on the other bank and so on, it takes less than a minute. It's trackable and it's available all the time. And yeah, when you see that and have seen what you had before, that is a real benefit, right? So that is absolutely great. Coming back to the question if Bitcoin has achieved the goals, actually, we need to ask ourselves now, has cryptocurrency in general achieved the goals? And here we can say, no, we don't have a common currency, because just in this example that we've seen, we have two currencies that are not everyday currencies and that are only used by two entities and not by private people or something like that. But we have definitely less exchange cost. One thing that we still need to check is the cryptographic proof. And to do that, we need to have a look at the technology behind crypto. So when talking about that, one thing we need to think about is how distributed systems work in general, because all these networks, independent of its Bitcoin, Ethereum, or Hedera, or anything else, is based on a distributed system. So you have multiple nodes running the software. And when you at university and talk about distributed systems, one thing that you normally learn is about scalability, where people tell you, yeah, so the more PCs you put into a distributed system, the faster it will be. Because let's think about microservices or something like that. When a transaction comes in, it's handled once on one node, and the more nodes you have, the more transaction you can execute within a second. And this is wrong when talking about distributed ledgers. Because when talking about distributed ledgers, every transaction that comes to the network need to be executed by every node on the network. By doing so, you create a trust. Let's assume you have one node and you do a transaction and the node has some kind of problem, and based on that, an error happens. Yeah, then you need to live with the error. If you have like 5 nodes and this one node has an error, you have 4 nodes that do not have that error. And based on that, you can say like, oh, 4 do not have an error, 1 have an error. Let's trust those 4 because they are more. That is the simplest way how you can think about it. And this is how scaling a network in a distributed ledger, where every node needs to execute everything, really creates trust, especially if, like, as you can see on the pictures, the nodes are really like shared across different countries, companies, individuals, and so on and so on. The thing that is true for distributed ledgers, like any other distributed system, is the fault tolerance, that this has a big plus in distributed system in general, because in microservices or a distributed ledger, one node can simply be turned off and the system is still working. On the one hand, it gets slower. On the other one, the trust maybe goes down. To do that, having it executed on each node in the network, we need something that is called the consensus mechanism. To say at the end, like, oh, okay, now we have executed everywhere, but we need one node, or we need somebody who says like, okay, and this is now the fact. This is now what is the common state between all the nodes. And this is what we call consensus. And there are 2 famous consensus mechanisms. One is called proof of work, and the other one is called proof of stake. Let's have a quite short look how those work. The proof of work is the one you maybe know about, because here a node needs to solve a complex mathematical problem to validate a block of transactions and say like, okay, that is like the state of the network now. Think about a puzzle, and the first one who solves it wins. Technically, it's like find a hash of all of this that starts with 4 zeros or something like that. And the node that is the first one to solve this puzzle will get some coins, which are created based on how much a transaction cost. So, and this is what we call mining, actually. So you have several nodes, and all nodes try to do this mathematical problem and find a solution. And the one who finds it first can define, okay, that is now the state of the network because I'm the one who solved the problem first, and I get some coins based on the transaction cost of all these transactions that are now new on the state. The problem with that is, since you need to solve a puzzle and do it over and over and over again, it costs a lot of resources. So here you see what the Bitcoin network costs in electricity consumption regarding length of our world. So you see here things like Poland, Malaysia, Ukraine, Pakistan, Norway, all around this yellow Bitcoin one, right? So the Bitcoin network today costs more electricity than Belgium or Finland, for example. And that is mind-blowing from my point of view. So while it's secure and you really have this checks, the resource consumption is a kind of problem. The fairness, I don't know, because software, so like better hardware, have a better chance to solve it. The other one is the proof of stake, as said. So this one means that nodes create a stake, which say they put a part of the crypto they have into a kind of safe, which is called the stake. And based on the stake, it is decided which node creates a new block. And if somebody fails on creating a new block because there is a hack in it, somebody tries to break the network by doing that, all the coins that are in the stake of that node will be lost for him. So you put money into a safe, and by putting that money, you give trust that you will work in a good way, actually, like that. And that is way more efficient. So Ethereum changed its mechanism from proof of work to proof of stake. And here you see some numbers regarding the electricity consumption, and you see that it's so much better than it was with proof of stake that is still used by the Bitcoin network. Well, again, this is kind of secure, and the resource consumption is way better. The fairness is, from my point of view, still a problem, because that leads to a situation like, okay, who has the most money will actually get the most money out of it. Because by putting a lot of coins in the stake, the chance that you can do or define the next block and get coins for it is way higher than having only some money. So you need to have already base money to get into it, and the rich people become more rich, actually, with that approach. But anyway, with all that approaches create a cryptographic proof that allow us to really create trust and to not need a single point where the money is like a bank. It's really in the network. So I added 2 more points to it, which is fairness and sustainability, because that is still kind of questionable. So now let's have a look at Ethereum as the second network we want to check. Let me just, give me a second. My second monitor is just frozen. I will try to get it back, actually. Give me a second. Okay, here we go. Okay, so let's have a look at Ethereum as the second network. So when I talk about Ethereum, I talk about like the second generation of crypto technologies, because it has a lot of more functionalities than the Bitcoin network, next to being way more sustainable, as we've already seen. So Ethereum has been invited by a white paper again in 2013, and the network started its operations 2 years later. And the important point of Ethereum is the EVM, the Ethereum virtual machine, because instead of just having one coin and allowing to do transactions on the network based on that coin, what Ethereum does and the EVM does, it allows you to execute code in the network, so-called smart contracts. And what you can do now is you can deploy code to the network, and when you execute the code will be executed on each and every node on the network. So you have code which execution is trusted. You can think about it like that. And that, next to doing transaction for coins, created a lot of new possibilities where it can be used for. One big is, for example, gaming, right? Because with having coins that you can use on such a network, you can not only store currencies on the network, you can store whatever you want to store. You can store tokens. And one example is this game which is called Axis Infinity, which is a quite big one. You can think about it like Pokemon on a blockchain, actually. And what you do here is a token is one of those creatures that you own, and each of them is unique, right? So it looks different, it has different strengths and so on. But since it's stored on the network, you can really trade with them, and they have freaking high prices. So this is, I put it now to dollars. So this is what you pay to get a really, I don't know, good one. Actually, I never played this game, right? So I cannot go into detail here. But this is what you can then do with Ethereum on it. And there are big companies like Ubisoft or Samsung that, for example, currently partnering with the companies that created those games. So it's not a niche market. It's really huge, really, really huge. And I assume I already mentioned Ether, which is like the native coin of the Ethereum network. And like Bitcoin, the price is quite high of an Ether. The difference is that for Ether, the goal was never to be a coin that you can use, or that you can use to buy a pizza for. It's more to pay the transactions on the network. So if you want to buy one of those animals, you need to pay a fee to the network that is defined in Ether. Okay, so when thinking about that, coming back to our question about all these checks, one thing we can say is the sustainability of Ethereum 2 is definitely way better than for Bitcoin, based on this switch from proof of work to proof of stake that happened some time ago. Fairness, yeah, as we said, is still not perfectly. Before we now continue to like the third generation of networks and see how you can use the EVM and smart contracts to create your own applications, I would like to have a short view on the overview of the sustainability of those networks in general. So we already seen this slide. If you want a more easier example that you can tell a friend, like when having a beer in a bar, is so the Bitcoin network could be used to power all tea kettles of the UK. to boil water, actually, which is really a lot, right? And the really fact is this one, not just once, no, for 30 years. And whoa, that is really, really, really high. As high was Ethereum before they moved from proof of work to proof of stake. Here we see the electricity consumption of Belgium, and here we see the electricity consumption of Ethereum 1.0. As said, they switched to proof of stake, and by doing so, the CO2 and power consumption really went down. You can compare it to this, actually. If the Bitcoin is a skyscraper, then you can think about Ethereum 1.0 as this is the, how is it called in London? The I thing. And Ethereum 2 against of that is really a kind of raspberry, right? So that is really much, much better. And we're really going down with the electricity consumption and so on, which is super important from my point of view. But let's compare this to other systems, right? I found some interesting numbers. I found numbers for PayPal, Netflix, and YouTube, how much electricity the data centers of those companies consume. And as you can see, even YouTube is only 10% of the Bitcoin network, right? So everything that YouTube is way, way higher than, for example, Netflix. I assume based on all this new technology that Netflix has, where they invented really a lot in microservices and so on and so on. Anyway, so as you can see, we are going to the right direction, but there's still things to improve. Which leads us to the third network I want to give an overview to before going to the generic part and showing how to do the technology, which is Hedera, and which is, from my point of view, the best sample for the third generation of networks. And what Hedera does, it takes all the cool stuff that we've seen so far and really makes it usable for the enterprise. And the Hedera network is based, again, on several nodes like Bitcoin or Ethereum does. The difference is that all those nodes are currently run by council members of the Hedera Foundation. There are a lot of members, actually, as you can see here in the picture. So we have like LG or German Telekom. What else do we have here? Oh, Google, for example, or Boeing. So a lot of big players that execute the networks of the Hedera Council. And not only big players, even players coming from different parts of the world, so that the Hedera network is split by companies, split by countries, and all those companies are even working in different sectors, right? So we have, let's go back, for example, with Mondelez, the company that creates the Oreo, right? So that is totally different than IBM, which again is totally different than Boeing, which again is totally different than a bank, for example, like the standard banks. So a lot of diversity in how the network is set up. But by setting it up like that and having the nodes be executed by that players, the sustainability is quite good, and it's carbon negative, as it is called. As you can see, the electricity consumption is way less than it is for Ethereum, which ends in having way less costs for doing one transaction. So actually, I do not know the concrete. I missed earlier today to check the current or today cost of an Ethereum transaction, but for Hedera it's less than 1 cent. And the amount of transactions that are done per day is way, way higher than it is for Ethereum, for example. So coming back to this picture, I added Hedera to it, and yeah, you can see that that is the next step when it comes to sustainability. And what we do not see here is speed, because the speed is quite high too. This one I updated today, where we had over 45 billion of transactions that are handled by the Hedera network. With, when I did the screenshot, over 1,000 transactions per second, and the independent USC Center for Blockchain Technology did some speed tests on the biggest networks on the market, and here you see that Hedera is by far the fastest one, way faster than Ethereum 2, for example. I don't want to get into technical details of that network, but it has a, based on how it's set up, a special consensus mechanism too. I added a barcode here if you are interested in that. So let's think more about how you can use it. And if you want to get started working with Web3 technologies, the Hedera network, for example, provides something which is called testnet, which is a network that you can use to play with. So for this network, you get H-bar, which is a native currency of the Hedera network. You get 10,000 H-bar per day, which is more than enough to play with the network and really do transactions, create your own code, play with it. There's a super user-friendly entrance where you just create an account in the portal. I added a barcode to scan here too. And then you can start playing with the network. Things you can do on the network, we've seen, for example, the POC that the Standard and the Xi'an Bank did. Some other things that are actually running on the Hedera network is an application from ServiceNow. They use the network to store information about the issue workflow for critical service level agreement customers. So you can think about like how let's use the Hedera network as a factor of trust to store like when a call comes in and things like that, so that nobody can later say, oh, you changed this data to meet the SLAs or something like to be within the definition of the SLA or something like that. Since it's outsourced to the Hedera network, you cannot just fake it. Another example is by Avery Dennison. I assume you never heard about this company. I neither did before I learned about that. That is a super big company in logistics. They, for example, do all the logistics for Essex, for the sport print Essex. And what they are doing is they store within the Hedera network like all the information where the parts of, like for example, an Essex shoe are coming from. And by doing so, they are super transparent, provide all this information in external platform in Hedera. And if, let's say, like a factory is doing malicious behavior to the workers or something like that, they cannot just say, oh, we've never worked with them. It's stored in the ledger. And here you then have the single point of trust, actually. So those are just some examples. Let's see what we can do with it. Oh yeah, and just to update that on Hedera, I would say that we are now at a point where all of that is achieved. Actually, not for 2 points, because that is nothing which Hedera or even Ethereum wants to do. So how can you create your own code on it? As we've already said, there's the EVM, the Ethereum virtual machine. And actually the same is used in Hedera and in other networks too, because that is becoming a standard, so that you can use the same smart contracts executed on Ethereum, on Hedera, or on other ledgers, based on the Ethereum virtual machine infrastructure that is running in the networks. And the interesting point is that you create it in a language like Solidity. It's then compiled to EVM-compatible bytecode and can be executed then on any EVM. The bytecode defines the opcodes, like really on byte level, like byte shifting, multiply, and so on. The interesting thing here is the gas section that defines how much does an opcode cost. So when you write code, deploy it to a ledger and call a function on it, it really goes down in the EVM to the opcodes that are executed, and every opcode has a cost, which means like you can really, by creating good code, be way more cost efficient than on any other platform. On the other hand, since your code is executed on the whole network, on every node, and no transactions are executed in parallel, it must not be possible to have one call executed endless. So what you always need to do is, when you create a transaction or start a transaction, say, what is the most cost that the maximum of cost that this transaction can have? And if this cost is reached because you have a bug in your software and it ends in an infinite loop, then it will be aborted once this cost is reached. To create an application, the most used language is Solidity, and I would definitely say to use that when creating smart contracts. It is well documented. You find a lot of examples online, and you can use that to create a contract, a smart contract. As you can see here in the sample, this is just a small smart contract. I won't go deep into like the programming language. If you are interested in that, I have videos on YouTube about that, how you can see how Solidity is working. So once you've written that, as said, you need to compile it to bytecode that is compatible to the EVM. And then you can deploy that contract on a ledger. And what you will receive is a unique identifier, which is the address of the deployed contract. And once you have this address, you can simply call methods on this contract. And so you can think about having a singleton deployed in the network where you can work with. You could even deploy it, so it's not a real singleton, because if you deploy it twice, you have two instances in the network. The second deployment will create a second address. And then you can use that one to execute code on it, actually. You can even have a constructor that is called automatically when it is deployed. So how can you interact with that? At the beginning, we've seen these wallets, right? And what the wallets are doing, especially if you just want to buy some Ether or sell some Ether or do other stuff, they can even work with smart contracts in some kind of ways. And what they are doing is they create transactions and send them to the ledger by using an API that is coming from the ledger. For Hedera, for example, there are APIs, all open source for all the common programming languages that are out there. You can just find them on GitHub. And if you create a smart contract, like shown, you can easily deploy it, for example, to the testnet of Hedera, and you have 3 HBAR there per day. You can just deploy it and call as many functions in general as you want, and really play with Solidity and the smart contracts and see how they behave. If you want to see more examples, I have some links at the end, and I have a lot of videos online where I show how to do that with Java and using the Java API. Next to this, one thing where all the people are talking about are like tokens, right? Like NFTs. So how does that fit into everything we've seen so far? And what is it actually? So a token or an NFT, you can think about it like, as we see here, like an NFT, like a digital Pokemon card, right? Which is a little bit different than a token. When talking about a token, we normally talk about an FT, a fungible token. An NFT is a non-fungible token. What's the difference? A fungible token you can think about like our money. One token has one exact price. And if you have another token, it has exactly the same price, right? So if you have like $1 bill and another dollar bill, both are worth $1. On the other side, if you have an NFT and you have one Pokemon card and another Pokemon card, the one can be worth 1 cent, the other can be worth, I don't know, $10,000 or something like that, right? Because it's not defined by the unit, how much worth it is. It's really defined by the internals of the token, how much worth it is. That's the difference between those types of tokens. And how is a token defined? Actually, and that's a big trick, each token is just a smart contract. And within all the specifications of the EVM, there are specifications now how a token should look like. And a regular token is defined by the ERC20 that defines an interface that a smart contract need to follow to be seen as a token with, here you see like, okay, what's the total supply of a token? What's the balance of a specific address, like a user? Here you can transfer money to, or here transfer from one user to another one, and so on and so on. And an NFT is more or less the same. It's again an interface for a smart contract. It has some more methods, but that's it. And that is a big benefit, right? Because by having this interface, services like Coinbase or whatever, once a new token come out, they can directly support it, since if the token implements this interface, you do not need to do a custom implementation to support a token. And if you want to play with that, there's one good project which is called Open Zeppelin, which is open source, that already contains those interfaces and contains documentation how you can use Solidity to just create your own token. One famous example that uses this is USDC, which is a stable coin that has already the same price as an US dollar. If you are in the crypto space, you definitely have heard about it. And this one is, as you can see, executed on several networks, and a lot of them uses ERC20 standard. So independent if you're on Ethereum or something else, you can just use it. And again, it's on Hedera too, and the sources are open source too. So you could just clone it and create something similar to USDC and deploy it and play with it. More easy if you want to play with it. I have a token workshop online, if you can scan the URL to get into it, that shows a step-by-step tutorial how you can create a smart contract and then implement a custom token, I call it the Java coin, in this smart contract, and then interact in a Java application with that coin. Another example I have online is an example for voting that creates a smart contract that you can use for secure and trustful voting software. And a very good source is the Hedera documentation too, since the example I've now shown are based on Hedera, but Ethereum and others have documentation too. So actually, we're running out of time. So that is what I prepared for now. I hope that was a good introduction for you regarding Web3, crypto, and distributed ledger technologies. So are there any questions?
Hello again, Hendrik. Thank you so much for the talk. Yeah, there are some questions, and since we have only like a few minutes left, let's jump right into it, I would
Absolutely.
say. First one, how do you stop people from stealing digital stuff and using it for NFTs without permission?
How do you stop people from stealing digital stuff? Yeah, I mean, the NFT, that's a big problem from my point of view. So an NFT, as said, is a token. So an NFT, for example, has nothing, first of all, to do with a PNG, right? Like with those ape PNGs. What people did at the beginning, they thought about, what we can easily do is we can easily store like the definition of a PNG, the link of a PNG into the metadata of a coin, and by doing of an NFT, and by doing so, referencing a PNG or picture with each NFT. And if we now create an algorithm that generate, I don't know, 1 million pictures, we can have 1 million NFTs that have different pictures, and maybe people like some of them and want to pay a bigger price of it. And you could do the same, and instead of generating pictures, just add pictures that already exist to it. It don't make sense from my point of view. And stealing, I mean, from my point of view, those NFTs do not have the worth of the price they are handled with, because I wouldn't call it stealing, because there is nothing you can steal. It's an image in the internet. Somebody says, like, if you buy this NFT, you have the NFT of this picture, which just don't make sense, right? So that's the point here.
All right. Thank you for clarifying this. We have time for one more question. Maybe this one, as it's a interesting topic. How do you ensure scalability and security in blockchain apps?
So the security, from my point of view, when talking about security, there was the cryptographic proof and there was the trust in general. So when I would create a blockchain app, I would always say, like, I create an app and there is some part in the app that uses the blockchain. And it makes sense to use a blockchain if you want to store the data and the information without having the ability to transform it later, which could even be like, I can transform an object, but the history will be always there. Or if you say, like, I have two players, like two companies that do not trust each other, so we use a network, a distributed ledger, as a technology to create a trust between those two partners. And the smaller the application, or the part of the application is that I put then in this network, the better. And by doing like that, you can do scalability. I mean, you can scale your app with microservices and have only a small part that is executed within the chain. And within the chain, so Bitcoin has a problem based on proof of work and so on, that it really takes a lot of time that a transaction is really done. On Hedera, for example, as we've seen, we are proved that we can do more than 10K transactions per second, which is quite near to what Visa or MasterCard can do actually. And there was, so we are already better today. That is the slides that I've seen is quite old, and we're working on it to really be more scalable, actually. Yeah.
All right. So big things ahead. All right.
So
Hendrik,
if there are more questions in the chat, I'm fine to go to the chat and answer them, actually. So if I don't know, if are there more, then I will jump over and answer them, then the people can stay in the chat.
Not directly in the chat.
Okay.
We just prepared some technical ones.
Perfect.
But I would say if some questions come up from the community, they can reach out also to you via your socials. So I would say let's do it.
Yeah.
Handle it this way. Also, if you have further materials or anything, please just send it to us. We can include it in the recap mail, which goes out on Friday. So I think we got it
Perfect.
covered here. So yeah, Hendrik, thank you so much for shedding some light on these topics. Thank you so much for joining, and hopefully we see each other again on another live day.
Thanks for having me.
Hendrik,
Bye.
thank you so much. Bye. All right, and we jump to the final speaker of the day. She's lead software developer at Scaling Parrots. Her team is focused on the blockchain app development, and she herself is also holding coding courses at meetups and also giving talks at events such as ours today. Very welcome, Soumaya. Hi, Soumaya, I think you're muted.
Hi.
Yeah.
Hi, everyone. Really happy to be here today.
Yeah, we are happy that we have you today, Soumaya. Thanks so much for joining. So before we jump into your talk, would you mind sharing a bit with us about everything about your topic, what it's all about?
Yes, today I want to talk about testing a Web3 application and how we can do it, the difficulties that we have to face when we need to test an application that have blockchain in it. And yeah, I will tell my story with it, how it was difficult and how I found a solution to that.
All right, story time with Soumaya. We're looking very much forward to your talk. And I would say, without further ado, the stage is all yours.
Thank you. So, as I said, today I'm talking about testing in Web3. I will introduce myself really quickly. I'm a developer lead at Scaling Parrots, is a small company in Italy. I work mainly with Web3 for the past 2.5 years, and I mainly do front end. And with Web3 is doing front end and integrating Web3 tools into my front end applications. And mainly this is my stack, Angular and React, or JavaScript, TypeScript tools. And yeah, I just love to talk about electronics and everything that is technology. So today I want to talk about something that developers don't like that much, that is testing. I used to hate doing testing because I didn't find the real motivation to do it. It was always something hard to do, and it wasn't working. And yeah, I had to do it, so I was doing it just because someone was telling me to do it, not because I really find a benefit of it. Until I actually had some troubles with project that wasn't tested enough, and yeah, that calls on the weekends and Saturdays made me realize what's actually the benefit of writing some tests. And actually, in the last years, I was working with Web3, and in particular with Web3, you don't have a backend that you have tested APIs that you are sure that will come with an error with it, and you know if it's failing, why it's failing. With Web3, it's a little bit different, so it's really important to have everything tested before going on production. So what is testing? Testing is, in particular in front end, is something that ensures that the quality of the application that you are realizing. And in particular, I'm going to talk about end-to-end testing. And it's a testing technique that verifies two things that I think they are fundamental for a good solution for our application. That is testing the functionalities and the performance of our application. And we can do that by simulating real user, replicating something that the user will do with our application. So I chosen this this tool for end-to-end testing because I really liked how it was like created the first time. Cypress is like an open source end-to-end testing framework and is like developed from developer to developer. So the developer experience is like the most important things, and the thing that the creator of Cypress like was really important to him. And in fact, if you go to the website of Cypress, you can find this quote that I think that is like actually amazing. This is: Cypress is an open source app, takes the pain out of front-end testing. So it's really make writing tests really easy. It's like really easy to set up, and yeah, it's the user experience is really good. The benefits and the advantages to use Cypress for me in particular is the real-time reloading, because it's like really fast and it reloads automatically, and it waits automatically to have the components of your application ready to use, so you don't have like to make any like slips or delay to make sure that the components are rendered and ready to use. It's auto waiting for the elements to be like ready and usable. It has a really easy setup, and it's really fast and has a great browser support. So yeah, that's amazing for all the application, but we are talking about Web3. So Web3, I like to explain Web3 doing a little bit of a comparison between what we know as like Web 2 or traditional web and Web3. So the main difference that when we talk about Web3, we talk about decentralized web. So we don't have like a central control. So Web 2 is like centralized and Web 3 is decentralized. So this is like the main difference when we talk about Web 3. And what does it mean? When we have like in Web 2 a central control, it means that we have like an authority that decides if what we are doing on the web is allowed or not. So for example, if I want to upload a video, I need to use someone else's like website. For example, I want to upload a video on YouTube. I need like the permission of YouTube to upload my video. So I can upload my video and YouTube can decide if my video is allowed or not. And if it's not allowed, it will be like jumped off and you cannot like say anything about it. So you can ask for explanation, but you will not like have any explanation about that. The only thing you can do, you can like try to upload it again and hope for the best. With Web3, you don't have to have the permission of anyone to upload your video or any content on the web. There are like some control of that by smart contract or any like code that actually has some rules of things that you can upload or not. And if what you are uploading is like following the laws of the code that is like open source, and you can actually read the rules of that web application, you can actually have your content on the web and it will not like be jumped off without any reason. So yeah, this is like the main thing that I really like about Web3. We have the identity. We don't have like to identify ourselves in the blockchain with in the Web3 with like our name or surname or our email, or we don't need like an email, a password. We just need to have our wallet, and our wallet will be our identifier, like our hashed address will be our identifier in the web. And also like for payments or any like asset transfers from a wallet to another, it's made like by default from the Web3. So great like differences between Web2 and Web3. But in particular, I want to focus about development. So what's changing between Web2 development and Web3 development? So what we are like used to is like a browser that is talking about with an application that sits all like served on a web server. And in the web server, we have the front end, our back end, and a database where we have all our data. So this is what we are used to. In Web3, it's a little bit different. We still have our browser that speaks with our web server. Our application is just a front end because we don't need a backend anymore. So the backend is substituted by a blockchain, in particular an Ethereum blockchain or any Ethereum compatible blockchains. And we have smart contracts that are just like computer programs that automate some actions to the blockchain. So instead of having a backend, we will have this smart contract that will communicate with our front end, gives us like the information that we need to show, and we can interact with the blockchain using that. To do that, like to make the centralized part that is like the front end speaks with the decentralized part that is the blockchain, we need provider. The provider is like this what allows this communication and can be like public providers. You can have like these URLs that are like RPC that you can find. One for every like blockchain has like public provider that you can use to read data from the blockchain. So if you just need to read data from the blockchain, you can use these free open providers. But if you want to interact with the blockchain, so write some data, sign some transaction, you need a provider from your wallet. So you need your wallet to sign anything you are doing on the blockchain. And also with our wallet, we can also like identify in our application. So we will not have a login or a register. We just have a connect wallet. We connect the wallet and we give like who we are, just like that. So what's the main difference between like a Web2 application and a Web3 application? In a Web2 application, we have login and sign up. Web3 application, we don't have it anymore. We just need a connect wallet, and this is our way to identify on our application. We don't need a database anymore because we are using the blockchain, and we don't need a backend anymore because we are using smart contracts. So what about Web3 developer tools? So what we need to know to build our Web3 application. So we need our front end, and can be any like JavaScript frameworks or library. It's in particular JavaScript. So because the Web3 libraries are for JavaScript, so this is like the easiest way to do it, just to use a JavaScript framework. We need a wallet, in particular for this session about testing. It's important to use MetaMask, but like for a Web3 application, you can use any like wallet you want. We need smart contracts, so we need to understand how smart contracts works, because we don't need like to know anything about smart contracts, because we are not building smart contracts. We just need to know how to interact with them. So smart contracts is just a computer program that is written in Solidity, and once is compiled, it will generate ABIs. ABIs are important for us for our front end because it's like a schema of what we can, what function we can use to interact with the smart contract. So every function of the smart contract will be translated into an object. So ABIs is an array of objects, and every object is a function of our smart contract. So we'll have like an object that has a name, and the name is the name of the function that we can call. We have the inputs that are all the arguments that we need to pass in the order that are like indicated, and we have the output, so what we'll receive as a return of that function, and we have an information that is state mutability, and it will tell us if this function is a function that will return us a data, so it's a read or it's a write. So if we are writing something on the blockchain using this function, or if we are just reading some data. So if state mutability is payable or not payable, it means that we are writing something on the blockchain. For example, this deposit, when we deposit some amounts from our into a smart contract, from our wallet to a smart contract, we are writing a transaction, and this transaction needs to be stored on the blockchain. So we are writing something. If we are just reading an information, for example, we are reading the name of a token, or we are reading the balance of our of that token in our wallet, we are just reading some information, and the state mutability will be view. In this case, it's just a read. And then we have Etherscan in this case are like explorers. There is a different explorers for every blockchain. And this is really important because every smart contract that is deployed is then available in the Explorer. You can like search by the address of this smart contract, and you will have all the information about the smart contract. We'll have all the transaction to and from the smart contract. We will have the code, because once it's deployed, it will be like open source, so you can like read all the Solidity code of this smart contract. You will have the ABIs. So for your front end, you will need the ABIs, and you can actually download it from the Explorer. And then you have this section of the contract where you can have read contract and write contract. And in these sections, you will have the list of all the functions that are in read, all the functions and that are in write, and you can test them. It's like having a postman or like a Swagger for our smart contract, and this like allows us to test and try on all the function of a smart contracts. It can be also like a double check for what you are doing on your application to make sure that you are integrating the function in the right way. So what's the operation that we need to know how to do in Web3? We need to know how to read an information from smart contract, how to write from a smart contract, and how to interact with our wallet, so our MetaMask wallet. From our wallet, we need just three information. We need the provider, because it will be our signer for our transaction. So we need to be able to have this information. We need the wallet address. it's really important because it will be our identifier. It's like the identifier of the user and the network. The network sometimes is like ignored, and I think it's really important because the smart contract will be deployed in a network, so in a blockchain, and we need to make sure that the wallet of the user that is connected to our application is connected on the same network that we are using on our application. Because if it's connected to another wallet, it will be like, in the best scenario, we'll have just an error, and sometimes is difficult to understand what error is. So we need to make sure that we are working on the same network to avoid any functionality that it's like not clear. So let's see our real example to make everything that we have talked about clear, and we can see how it actually works. So let's imagine to have a decentralized application, a Web3 application for DeFi that displays our balance of Boost and allows us to transfer Boost to other wallets. So what we need to use, we need to get our provider. To get our provider, we need to use this library that is Ethers. Ethers will be like our best friend in Web3 development, because everything with Ethers will be easy. To get our provider, in particular for MetaMask, we'll have the information in the window object. In the window object, in particular, we have Ethereum. So window.ethereum will be the provider of our MetaMask extension. So we need to translate this provider from our window to a provider that Ethers can work with. So we need to use this class Web3 provider from Ethers provider, and it will have like a Ethers provider that it's like we can actually use. And from the provider, we can get the signer, and from the signer, we'll get like the user address. So we have the provider and we have the user wallet. And then I had like this Boost object that is actually the address of the smart contract of Boost that we will use to make a read and a write. The ABIs, in this case, I've just shown you another way to write ABIs, and I think it's more like readable in this way. It's like two ways to display ABIs. You can display it as a string that is like the function informations as a string, or as an object. As an object, it will be like really long and harder to read. As strings, it's like my preference to display it. It's like two ways that you can find ABIs in applications. Then we need to create like a contract manager. In this case, is like a Boost contract, and we will use Ethers again with the class contract, and we'll pass the smart contract address of our smart contract that we want to recreate, that is the Boost address. The ABIs, you can pass all the ABIs of the smart contract or just the ABIs that you need in this case, and then the signer or the provider. Once we have our contract manager that is Boost contract, we can actually read the information of the balance. So we'll use this balance of, that is the function that will return us our balance. And we need to pass the address of the owner of the wallet that we want to read the balance of. And what we'll get a big number, actually, because smart contracts doesn't work with decimals, so we'll always receive big numbers, and then from the smart contract itself, you can read how many decimals you have in like your in this token, so you can like reformat your big number into like a number that we can read. In this case, I'm using the utils from Ethers that just formats my big number with 18 decimals, in this case for boost, and the result will be 9. Let's see the same, but for the transfer. So if we are writing a transaction into the blockchain, so we have the same contract manager, but we have like a transaction now. So we are doing a transfer, and we'll pass the address of the receiver, so who is receiving this amount, and the amount of tokens that we want to transfer. And once we do this transfer function, it will actually open up pop-up from MetaMask that will gives us all the information about this transaction that we are doing. So we'll have like how many tokens we are transferring, how we'll pay, how many fees we are paying, whom we are transferring these assets to, and we can reject or confirm our transaction. If we confirm, we'll have our, we can do this transaction.wait, and we can actually wait until the transaction is actually confirmed and stored in the blockchain. We can have all the information like the block number and where it's actually is stored, the information. Okay, so this is how we build and we interact with the blockchain. What about testing? For testing, so there are too many things that we need to test in our application because are like different from traditional applications, and are the smart contract and the wallet. So we need to test the interaction with the wallet, and we need to test also these smart contract functions. So for the wallet connection, and also like to confirm or reject a transaction, this is like making a little bit difficult to test because we are not operating on the same window of our application, because we are opening a pop-up. So this is like the difficult part, because we cannot actually go and click a button that is outside our application. So to do that, there are two options. Actually, for like many years, there was just the first option, that is like to use any end-to-end testing tools and then just mock the Web3 interaction. We are not actually testing what is going on the wallet, and this was really a problem for our applications, but it was like the only option, because there was no way that it was possible to actually interact with something that it's not on the same window. And then we have actually another option that is using a Cypress wrapper that has MetaMask support. And it actually is a tool that named Cypress, and it actually helps us to use to actually test our decentralized application, our Web3 application, and it's a framework that is built on top of Cypress and Playwright. So we can use the two tools. In this case, I'm using Cypress, but also it's working really well with Playwright too. And for now, we just have support for MetaMask. So that's why we are sticking with MetaMask, and we will try it with MetaMask because it has support just for that. But it's like, for now, it's really enough for doing testing, because it's just for testing. And actually, it has a good support, and yeah, it's working really good. So here you have all like the information about Simpress. You can find a great documentation, and also like all the commands of Simpress that you can use with Cypress and also with Playwright. So there are already written commands, and also, like, since it's like open source, you can write your own commands. So you can add all the commands that you want. You can like go to their website and see how it actually works to write a command, and then you can write your own if you need like any other command, like specific or so. So okay, let's see like a real demo and see how actually it works, how Cypress it works, and Simpress in particular with our Web3 application. I just want to show you really quick the Simpress repository, and you can find like all the documentation, all like the information about the new releases. They are working like they are contributing a lot on this project. So you will find new commands and new informations about it like every time. And here you have also like all the list of commands that you can like use, and like you can use it like a documentation if you are like just a beginner, if you need like to know how to use a command. And this is like a MetaMask end-to-end test application that MetaMask actually have developed to make sure that you can like try on all the wallet interactions to like just connect to wallet, read information, but also like how to interact with tokens, or how to deploy a smart contract. And this is like useful if you want like to understand how you can write some tests. It's like a helper for writing tests, and like before writing it on your actual application. So yeah, let's go to the code. I here have installed this MetaMask test dApp that I'm going to use as my front end, and I had some tests written. In this case, I've written some tests about Connect Wallet. I have a lot. I will show you like the Connect Wallet and the NFT one because it's a little bit tricky. For like the Cypress part, the testing part, we have Cypress installed, of course, and also Simpress. So we need Simpress and Cypress, or like Playwright if you are using Playwright. And then I have just some scripts to run the application, to run on my tests. And I like to use this start server and test to make my my server start and run my tests. Let's see how we need to configure Cypress. So when we install Cypress, we'll have this Cypress directory auto-generated, and we'll have this end-to-end directory where we have our actual tests file. We have some fixtures if we want some fixture. I actually don't use it that much. And then we have like commands. In this case, those are just like the Simpress commands, but you can add your own in here and import these ones from Simpress. And then you have this end-to-end.js where you have to import the commands. And this is just auto-generated, just using some little configuration about how it's running. And also here we have like the setup of MetaMask at the beginning of our tests. And then we need this Cypress configuration. This is really important because here we are, we need to configure Cypress for our application. So we are telling our application that we are using Cypress for our tests. We need to set our timeouts. We are using a timeout a little bit like delayed. That is 30 seconds. That is a lot actually, but because we are using blockchain and we need like to have some extra time, also like to wait for our browser extension to respond, our MetaMask wallet to respond. So sometimes it will need some extra time. So sometimes you can have like some errors that are not actual errors, it's just taking much time. So 30 seconds, it's a good amount of time to have everything covered. And yeah, it will like skip it if it will have the information before that. But it's important to have the timing for making sure to have the response of the transaction. And then we have to declare like the support file, the browser, the base URL of the application where it's served, and that we are using the Cypress plugin. And yeah, we can make sure that we have written all the test commands that we want to run. So I've written, I also always start with setting up MetaMask because we are downloading MetaMask and we need to set up our MetaMask wallet, as it's like the first time that we are seeing it. So I use like my secret words, or you can use like your private key. This is actually like fake wallet that I use for my tests, but actually don't share your secrets with anyone. This is like really a case just to make sure that it's working, but actually don't do it. You need to declare the network. I'm using Sepolia for this one, and a password for your wallet. And then we are expecting that the setup is done and it's true. And then I'm doing some connections. We need to make sure that we are visiting actually our application. We have like this connect button is the ID of the element button of the connect wallet. And we need to click on this. And we want to reject MetaMask access. And this is actually a command from Cypress. So we are telling Cypress to use this command that is it will be like clicking on the reject of MetaMask pop-up. And then we are expecting that it will be rejected. And then I am accepting actually. So we'll accept MetaMask access. So same thing, it's a Cypress command that will click on the confirm button. So we are accepting the connection in this case, and we are reading some information. So we need to make sure that the networks is the network of Sepolia, the chain ID is the chain ID of Sepolia, and we make sure that the account that is connected is this account that is actually my wallet address. And then I have also like this Ethereum account. We are getting like information about our account, and we are making sure that the wallet displayed is the actual wallet that we are connecting to. Then I have an import of a MetaMask account with my private key, and we are making sure that we are accepting the MetaMask access, and the account has actually the wallet address that is the one that we are connecting to. Then we'll try to create a MetaMask account with like a default name. We will create an account with a custom name, and then we will try to recreate another like MetaMask account with the same name, and we expect like an account that is already existing, so it will we are expecting it to fail, and then we will try to switch our MetaMask account. We'll try to get our new MetaMask account as we have switched account. We can switch account using the account name, and then we will try to get our wallet again, and then we will just reset MetaMask account. So we'll try to disconnect from our application, and that's it for the Connect wallet. So let's see if those are working. I hope they are, and let's see how Cypress actually works with that. So once we are running, so Cypress will run and open up a browser. It's actually opening and downloading MetaMask and creating a new account. So here we have the account. We'll switch to Sepolia network, and we'll try to get the information. So we are connecting the wallet, reject, and then we are connecting and accepting the information. We will get the account. We'll try to import a new account, create new accounts. It's actually really fast. It's doing everything really fast, but you can actually see what it's doing. And then, yeah, all the tests are passed, and you can have actually all the reports about your testing. And here you have that actually all the tests has passed, and you have like, there was like 13 tests passed. You have also like this video output that you can actually rewatch to see how it's actually performed. And here in the Cypress directory, it has created a new directory that is videos. And here you can have your video that you can actually rewatch to see how it's actually performed. And I think this is great. We'll see really quick the NFT one, just because the NFT one has this part that is like deploying an actually smart contract that will take a little bit of time extra. And I wanted to show you why the 30 seconds. In this case, it will actually use the most of the time of the delay. So it will be like interesting, like just to show this part. The first part is like the same. It will like configure a new MetaMask wallet, will generate the wallet, and then like switch to Sepolia. And then we have to connect our wallet and then deploy the NFT smart contract. So yeah, we are deploying, and here you can see it like that is like taking, this is like the 30 seconds, and it's taking a lot of time to mint our NFT. And then if we don't give him like the 30 seconds, it can like fail without like any reason, and will not like have like real motivation that we can. Okay, so yeah, this is like the most like slow part of an application that will take like most of the time. So yeah, this is it. So let's go back here. So yeah, if you want the code of this demo that we just seen, you can find it on my GitHub. It's a Cypress demo, and yeah, you can like try it out, or let me know if there is a better way to do it. I'm always open to a discussion about it. And yeah, here you can find all like my you can find me on all my social media if you want to reach out. And yeah, thank you very much.
Soumaya, hello again. No, thank you for your amazing talk. So we
Thank
still
you.
got some minutes left, I would say. Let's fill them with the questions we got.
Yes.
Go on, go. All right. How do you stay on top of changes in testing methods and technology as Web3 evolves, of course?
Yes, it's actually a little bit difficult because like there are two things that navigate in two directions, because like Web3 is evolving, but also like the web tools are evolving. So sometimes like you need to stay up with the web, but also like with Web3. So yeah, you need to make sure to be like up to date in both direction, but also there are a lot of tools that makes them work together. And yeah, if there is no solution, sometimes you need to find a solution and to build the solution yourself.
Be crafty, yeah.
Yes.
Right. Thank you for that answer. Next question. What tools do you recommend for testing Web3 apps, and why do you use them?
So I actually recommend Cypress with Cypress, but also with Playwright. I used to use Cypress before, like working with Web3, and I really liked it. And that's why when I switched to Web3 and I found the solution for Cypress, I stick with that. But actually, in the last like 6 months or so, I started using Playwright, and I think it's actually amazing. It's like the younger one from the testing tools that are like more used, let's say. And then you sometimes cannot like find the same support that you have with Cypress, for example, but still is really good, and it's working it's really fast also. And yeah, I think they both are good good solutions.
All right. Thanks for these tips. So, next question. Any tips for keeping Web3 apps safe and reliable while testing? Like, how do you make sure everything's secure? That rhymed.
Yes. So while testing, first thing you need to like stick with testing networks. So don't use real blockchain, don't use real assets like real money. So like stick with the testing part, and like you are pretty sure that you are safe in that case, just for testing, because you don't want to test on mainnet. We don't actually do that tests. We do real one tests with like real like networks, but we make sure that we are testing 100% everything in the test net, and then yeah, we are like sure that everything is working and you can do and go in production with without like caring too much. You can also find some wallets that are like open, like the Hard Hat wallet that you can like use. Everyone is using like for testing if you don't want to use like your own. But actually, I think that it's safe to use also like your like a dedicated wallet that you can use like for testnet.
Thank you so much. We got one more question from the audience. What approaches do you recommend for simulating real-world conditions and edge cases during testing for Web3 applications?
So, yeah, I think that you, as the developer of your application, if because also sometimes the application is not tested from the developer that is developing actually the application. So you need to make sure that you are aware of all the functionalities that you have on your application. So make sure that you are talking also to the developer that is creating that. And I think that you need to cover all the steps of the application. So it's like you are presenting your application to your client that asks for this application, and make sure that you have covered 100% all the steps, all the requirements that you had, and like fake user interface with the application. Like you want that user to try on everything that you have built. And so if you are simulating everything, you make sure that your Web3 application is 100% tested.
All right, thank you for that. And maybe to close the session, you're a lead developer. Would you mind sharing a bit with us about how you first got interested in tech from the beginning and which steps brought you to where you are now?
So actually, I've I started with tech in a weird way because I started in university, but actually I chosen like computer science because I didn't know what else to do. So I wasn't like that kid that was like interested in technology, was passionate about it. It was just like, I was there. I liked it, and like my journey starts from there. I had some experiences because at the beginning I wasn't like 100% sure. I was also like the only girl in like 200 people in university.
Oh.
So it was like maybe it's not the place for me. But yeah, it was a journey actually. But yeah, I think that I've found something that I really like, and I really like to do it as my job because it doesn't feel like a job, because I'm really enjoying it. And yeah, as a developer lead, I actually also like a lot to make other like developers that works with me feel comfortable, and also like to love doing what we are doing, and to make their life easier a little bit.
Yeah. Oh, I think we lost the audio right there. One second, please. Hello? Soumaya, can you... Okay, sorry, we got some technical problems here as it seems. Sorry, I'm not able to hear you anymore. So, sorry for that. One second. let's use the backup. Ja, aber ich sehe nicht.
That's better.
Ah, no, now you're back. All right. Then, all right. Yeah. Thank you for sharing your story also, Soumaya. It was inspiring. And
Thank
also,
you.
I mean, you don't know what to do and then you go into computer science. What?
Yes.
I love that part. All right. Soumaya, then thank you so much for sharing all these details today with us. You really shed some light on some interesting stuff, I would say. And yeah, hopefully we see each other again on another live day.
Yeah. Thank you very much. Thank you for having me.
Thanks, Soumaya. Bye.
Bye.
All right, and now that also this live day comes to an end, just some further informations. Thanks to our partners, of course. You can scroll down on the live page and click on their logos. They are clickable. Check them all out. Also, don't forget now to go to worldcongress.dev if you're interested in our flagship event this year in Berlin. And also, if you're interested in this thing here I hit during the whole event today, we will publish more information about our next Code 100 stuff soon. To get all the info, you can also go to code100.dev and scroll down there. You can subscribe to our newsletter. This way you can make sure to not miss anything. All right, and hopefully we all see each other again on the next live day. It's on April 24th and it's all about the cloud. See you then. Stay tuned. Bye.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.